All right, doing take two on this because somehow the audio got fucked up on the live stream, even though I didn't change any settings and I sound fine right now. Let's give this another shot. So today I wanted to do a video on kind of the weird operators in Python. What do I mean by the weird operators? What I mean is there's lots of operators in Python that sort of make sense to a beginner, right? If I say x equals 5, you know that x is set the value of 5. If I say y is equal to x plus 5, you know that y is going to be equal to 5 added to x, right? So 5 plus 5 is going to be 10. All right, and if I play that, cool, VS Code doesn't work anymore. Just do python exp.py, and you get the value of 10, right? No surprises there. And of course, all the other math operators work just the way you'd think, right? Minus for minus, times for star for times, and a divide for division. If you've ever used a calculator before, you already kind of know all these. All right, so let me talk about the ones that are a little bit weirder, right? The ones that you might not be so familiar with. And let me start with exponentiation, right? So let's say we wanted to do something like x squared here, right? 5 squared should give me 25. Now, the way we do this in Python is with this little double star. If you weren't thinking, or if you've gotten really used to a calculator, you might have thought that it should be something like this, right? X squared. That kind of looks like a square, doesn't it? But if I run that program, I'm going to get 7, right? Which is obviously not what I want, right? I want a 25 for this one. So what's going on here? This little operator is actually called the bitwise XOR. And this is pretty common in other languages to see it this way too. What this does is it takes the number in binary and does an XOR operation across them. Basically, if both numbers are 1 or if both numbers are 0, it gives you the value of 0. I'm not going to go too much into binary because this is an intro to programming class, but the basic way you would do it, if you've taken discrete structures before, you know that 5 is 1, 0, 1. You know that 2 is 0, 1, 0. And you see I get 1 or 1 is 1. 0 XOR 1 is 1. And 1 XOR 0 is 1, which is the number 7. But if you're a beginner, all you really have to know is that exponentiation is just this little double guy, right? If you do it the other way and you see something not expected, that means you're using the wrong operator. Right? I don't think I have to say anything much else besides that on that one. Let's talk about the other weird guy, modulus and integer division. All this stuff down. So, what is modulus? Modulus looks like a percent sign, and this doesn't give you like the percent of a number, right? Like if I said print 5% 20, or 5% of 100, right? Let's keep it easy. And I go ahead and play that. Right, that's going to give me the number 5, which is not 5% of 100. Well, it is actually. That one worked out. Let me take a better example. Let's say 5% of 200. Right, that one should actually be 10, right? But this one also gives me 5. So this does not calculate the percentage. What it does is calculate the remainder of something. And this is kind of like how you did division back when you were in grade school, right, with long division, where you said something goes in a certain amount of times without going over. Let's do like a simple example. Let's say like the number 12. Actually, you know what? Let's make it odd. Let's say it's 13. And let's say we wanted to divide that number by 6. Python will do this just fine, right? 13 divided by 6. And you get 2.16, whatever. But sometimes it's helpful to express it as both it's helpful to do it in decimal form sometimes, but sometimes it's helpful to do it as a number, remainder, another number. Right, and that'll look something like this. I'm going to put an R here just to separate them. 13% 6 will give me the remainder. So what it's going to do is 13 divided by 6, what's left over. And the integer division is going to just take this part of the number, right? It's going to get rid of all the decimal places. I'm going to go ahead and save that. And you'll see that now I get 2 remainder 1, right? 6 goes in twice without going over, and there's 1 left over. Why is this useful for a program? Why do we care? Well, there's a couple reasons. I think the best or the most obvious application for this is units, specifically a unit of time. Right, like in our last example, like last week when we did the length of movies, we had some movies that were like something like 137 minutes, right? I'll just say this is in minutes just to make that clear for me. This is in minutes. right? And what I could do is I could display it in minutes. That's fine. You know, that's not necessarily a wrong answer. Right? For 137 minutes, I could say, make it more of a sentence, say the movie was, comma, movie minutes. But what if I wanted this in hours? Well, your first thought is probably just divide by 60, right? 60 minutes an hour, and just divide by 60. That's fine. That's like one good answer. But it might not be the display your user wants. All right, so this will tell the user that their movie was 2.283 minutes long. I don't know anybody who knows how to figure out what this is off the top of their head. I don't know how many minutes that is. And actually, I'm sorry, this should be hours, right? Because we're converting to hours. Mouse there. Right, we're converting to hours. Okay, so it says 2.283 hours, but 0.283 hours is not really a realistic quantity. Nobody knows what that means. So it's probably more helpful to put this in minutes. And for this, we can use remainder and stuff. So for the hours part of this, all we care is how many times does 60 go in without going over, right? For that part, that's easy. That's just double divide. Okay, so the movie was 2 hours with some left over. How do we get the leftover part? We use the modulus. That's going to look something like this. Movie percent 60 minutes. Right? That's just how many times does 60 go in and how much is left over. So it goes in twice. There should be 17 minutes left over. Let's see if that's what we get. And that's exactly what we get, right? So this is a convenient way to kind of break up your units a little bit. And so it's a pretty common thing to see in programming. It's called modular arithmetic, if you're curious about learning more about it. Another way of thinking about it, so that's one way, but I also want to give this other way. This is sort of the more traditional way of thinking about it. Let me go back to what I had before. That was it. No, go back. There we go. Perfect. So another way to think of modular arithmetic is, what if we only had a limited set of numbers, right? Like for a clock, for example. Let me get an image of an analog clock just as an example. Analog clock. Because in the year 2024, how often do we even see these? Right? The analog clock has an hour hand, this little hand, that goes up to 12 and then resets back to 1. Right? There's a lot of things in life that are like this. Minutes are like this. Once you get to 59 minutes, it goes back over. Right? So any kind of cyclical counting system can be expressed in modular arithmetic. And I'll show you exactly how. So I wrote a little program here. Let me go ahead and just kind of do it from scratch again. Right, so let's say we only had the hours 1 through 12. So the way we might do this for a clock is, let's say the current hour, for example, is 12, and we want to know what it's going to be in 5 hours. So next hour we'll say is 5. To calculate the next hour, the calculated hour, you could just do 12 plus 5, right? Or, sorry, current hour plus next hour. But the problem is, if we're limiting ourselves to 12 numbers, like on the analog clock, right, where we only have 12 numbers, we can't use the number 17 here. We have to go back and count. All right, so a really convenient way to do that is just to add the numbers and divide out 12, and then just look at what's left over. If you're under, all it's going to give you is the number, right? So if I'm 11 divided by 12, there's 11 left over, right? So you get 11. If I put in 13 divided by 12, I'm going to get 1 left over, right? 1. If I put in 17, well, let's see. Right, so let's print this calculated hour. Okay, so in 5 hours, it's going to be 5 o'clock. Let's do something a little more exciting. Right, so from 10, if I add 5 hours to this, it should be 3 o'clock. And it is. Okay, let's make this a little more user-friendly, something the user can control. So we'll let them enter the current hour. So I'll say int input. What? Whoops, I screwed up the quotes there. What is the current hour? Okay. How many hours? Input. how many hours should pass. And this is going to be the same, right? Because we're just putting in a number in here. And print the calculated hour. All right, so now we can actually control this, right? The user can supply some numbers to us. So we could say, let's say it's 10. Let's say 4 hours past should be 2 o'clock. So proved. We have a program that works kind of like a clock. Now, there's going to be one issue with this, which you won't run into with the 24-hour clock, right? So let me just run Analogy real quick, show the whole code real quick, and so you can review it. Think carefully for a 24-hour clock. What number is going to change here? And what problems do we have with this current code? So I'll show you the problem with this current code, and this won't be an issue for the 24-hour clock, actually. The 24-hour clock is easier. But for this one, we're going to run into a problem when we have when we get to hour 12, right? So let's say we're at, it's 10 o'clock, and we want to see in 2 hours, it should be 12 o'clock. But this says 0 o'clock. If we were doing the 24-hour clock, be fine, right? There is a 0 o'clock. The first hour of the day is called 0, but not so in 12 hours. So for this one, we're going to need one extra thing here, something called a condition, which we're going to talk a little bit about next class. And the condition here is basically, if the calculated hour is 0, you want to set it to 12. So if calculated hour, we're going to use double equals to compare. So if it equals, sorry, not 12, but 0, we want to set it to 12 instead. All right, and now this will be exactly the hour hand on that clock. 10, 2. All right, and just to verify why that's happening, so do the math, right? We put in a 10 for the current hour, so 10 plus 2, so it gets you 12, and then 12 divided by 12 is 1, remainder 0, right? So we get a 0 in the remainder. Okay, so that is the basics of the weird operators in Python, right? Exponentiation and integer division, and some uses for it. Hope that helps with the problems this week. And I'll see you guys again, hopefully at next office hours on Tuesday. And hopefully I'll be a little better then, and not with this terrible cold that's ruining my voice. See you next time.